Hi students, and welcome to another preliminary chemistry video. This one part of the Chemical Earth series, and in this one we're going to have a little bit of a look at Lewis structures. Now, one of the problems that we've had in looking at atomic structure and in looking at how atoms become ions is how complicated an atom can become, particularly if it has a large number of electrons. So we want to try and simplify what's going on. Now, we've done with this previously with things like an electron configuration, but even these can get a little bit unwieldy. If we look at something like hydrogen, well, it's 1. Lithium would be 2 and 1. Calcium, on the other hand, would be 2.8.8.2. This starts to become itself a little bit unwieldy and a little tedious. And the only thing that we're really interested in is the outer shell or the valence shell. So for hydrogen, we want to know that it's got 1. For lithium, we want to know that it's got 1. And for calcium, we want to know that it's got 2. So all of the other stuff that's happening inside those inner shells is less important when the electrons are being gained, lost, or shared during the formation of compounds. One way of showing this is using a structure called an electron dot diagram or structure, or a Lewis diagram. So we can show this quite easily by looking at what's happening in just the outer shell. Remember, this is about the outer shell or valence shell only. So sodium has a single electron in that outer shell. What it does is it loses that electron. That electron becomes lost from that outer shell, and as a result, the sodium has no electrons in its outer shell, but as a result has a positive charge. Now you can see there are actually no dots around this. The dots are representing electrons. Now this gets even more interesting when we look at how they combine together and we use different symbols to represent the dots. So for chlorine, let me show chlorine has an arrangement. So sodium has an electron configuration of 281. I'll put chlorines down as 287 as a contrast. And it's just the valence electrons that are important. But I'm going to, instead of doing them as dots, I'm going to do them as crosses. 2, 4, 5, 6, and 7. Now the difference this time is the chlorine is actually going to gain an electron. It's going to get an electron coming in. The consequence of that is that it will have its original 7, and let's say it has 1 from that sodium. So I'm going to put an extra dot in there. The consequence of this, of course, is that this species is now an ion and it has a negative charge. These are called Lewis diagrams after after Lewis, who was a chemist who did a lot of work on structure of acids or definitions around acids. And it gives us a bit of an idea about how we can represent what's going on with different atoms as they combine. Electron dot diagrams are probably even more useful when we show covalent bonding. So covalent bonding is where electrons are shared. So hydrogen will have 1. Let me make it a cross, and this hydrogen also has 1, and the oxygen has 6 in its outer shell. So I'm going to just put the 6 like this. So what's going to happen is we're going to have both of these wanting to gain. So the best way for this to happen is a bit of a sharing arrangement going on between these two. As a consequence, we get a dot and a cross, a dot and a cross, and then 2 dots and 2 dots around the oxygen. This can be shown as a bond as well. So the hydrogen bonding to the oxygen, bonding to another hydrogen, and that shows the electrons that are involved in the bonds. And then we put those other 4 electrons in to show the unbonded. These are unbonded electrons, whilst obviously these are the bonded electrons. So these are quite useful structures in order to show us how covalent compounds are bonding or sharing electrons. So let's have a quick look then at two more examples, the formation of magnesium sulfide and also the formation of ammonia. You might want to stop the recording, have a little bit of a go at this yourself and then make a comparison. So the outer shell of magnesium then has 2 electrons. So let me make this 1, 2. And it's going to combine with sulfur, which has 6 electrons. It's in the same group as oxygen, so it has 6. So therefore, it's going to form a compound of magnesium sulfide. But because these are going to be ions, the magnesium is going to have no electrons left. It's going to have a 2+ charge. And we're going to have the sulfur with its original 6 plus the 2 that it's gained from the magnesium to form a 2- charge. Now, because these are opposite charges, they will attract and will form an ionic bond. Ammonia, on the other hand, is a compound formed between nitrogen and hydrogen. The formation has 5 electrons around the nitrogen, and there's obviously 1 around each in the outer shell of each hydrogen. So when these ones bond together, we get an arrangement where we have an unbonded pair for the nitrogen, but the rest of them will be bonded pairs. And another way of representing that, as we've looked at before, is to have N bond H, bond H, bond H, and then the 2 unbonded pairs at the top here. How did you go?